All right, the fundamental theorem of calculus. Let's talk about that. Fundamental theorem of calculus. Whoop, that's right up there. Okay, so the fundamental theorem of calculus really formalizes two ideas that we've talked about before. So, two ideas. The first one that we've talked about is that an integral is just representative of an area beneath a curve. So integral equals area beneath a curve. And then the second idea is that the area function of this is just the antiderivative. So the area function, which, aka integral, that equals the antiderivative. Then we'll just add from A to B. All right, so we have some function f of x, and let's say we want to take the integral from a to b of this function f of x dx. Well, we're going to do this by taking the antiderivative, or we're working backwards. We're saying, what would the derivative of this have to be to get back to the function? So we're working backwards on the derivative, and you take the antiderivative of b, and you're going to subtract the antiderivative of a. Or another way to say this would be that you're going to take the integral at b and subtract the integral at a. So let's take a look at this in action. It's kind of one of those things that when you see it, it starts to make a lot more sense. So let's start with a function. Let's say, how about we'll do f of x equals x cubed minus 4x. All right, and let's take a look at what that looks like first. So here we've got our graphing program, and we'll just say y equals x cubed minus 4x, and there we go. All right, so let's just to kind of illustrate this, let's go from -2 to 2. All right, so we're just going to be looking at here to here. So I'm just going to sketch this real fast on our page so that we'll have it to work with. 1, 2, and a little bit, and then 1, 2. Okay, sorry, hang with me while I sketch. 1, 2. Okay, and then it comes up and down and up. Okay, and let's get back to my beautiful sketch. Voila, an exact representation. Maybe not. Looks really not a lot like it, but it'll work with how we're doing things today. So we're going from -2, and it goes through 0, and then we're going to look at this from 2. So let's say we want to figure out, well, what's the area underneath this curve from -2 to 2. So just for fun, let's break this up. Let's go from -2 to 0. Then let's go from 0 to 2. Then let's look at the whole thing from -2 to 2. So the first thing that we have to do, first step, is we got to figure out what the antiderivative of this is. So I go little integral symbol of x cubed minus 4x, and then this would be dx. Okay, well, I can simplify this a little. Let's go integral of x cubed minus 4 integral of x. And these should both have dx's on there, but this is just kind of to illustrate, so it won't be super complete. All right, so if I'm taking the integral of this, remember when we're doing antiderivatives, we're just going to take this number and add 1 to it. So that's x to the 4. Then I'm going to divide it by that same number. All right, then I've got 4 times, same thing up here, x to the 1, so I'm going to add 1 to it, so that's 2, and I'm going to divide by it. Then don't forget that c. Don't forget to add that one, there's a constant there that we can't really see. All right, so let's simplify this just one more step. All right, this is going to stay the same, so I've got x to the 4th over 4 minus 4 divided by 2, that's just 2 x squared. And then we'll just add that plus c for now, just as a good reminder, but it's gonna, as you'll see, it'll kind of drop off when we're doing our analysis from our definite numbers. So okay, so let's take a look at this now. So I figured this out. First off, so now I've got my antiderivative, so let's go from first -2 to 0. So I've got x to the 4th over 4 minus 2 x squared, and the way that you write this is you just put a big line over there. You say from -2 to 0. So from -2 to 0, that is, I'm just figuring out what's the area in this, and from here to here, right, and underneath this curve. So we can get our calculators out if we want, because these can get a little more complicated. This one's not so bad, but all right. So I'm going to do -2 up to the 4th divided by 4. So that's 4 minus, and I'm going to do 2 times -2 up squared, and that'll give me -4. Okay, so I figured out this at -2. The first thing I want to do really is figure it out at 0. Oops, because we do f of b, so we're going from this. So f of b, that's just going to be 0 minus 0, so that's 0. Then I figured this out at -2, which, again, that's what we did on here, is going to be -4. So I've got 0 minus -4. So I know that the area underneath this curve right here equals +4. All right, and that makes sense because you see this is above your x-axis. Anything above the x-axis is going to have a positive area. Okay, so let's do the exact same thing, only this time we're going to go from 0 to 2. So just as a little trick, I know that since this is even and that's an even value, that at 2 and -2, this is going to give me the same value. So I've got -4, because remember, you figure out the top one first, then you subtract it from the bottom one. So I've got -4 minus 0. So that just equals -4 minus 0. That's -4. So that means this area under this curve is going to give me -4. So let's think about this for a little bit. You can have the net area, as in what's going to be the total area, and that's just the absolute value of this area and this area. So really, I have a net area of 8 because it's 4 and 4. However, the cool thing about integrals and integration is it takes into account positive and negative values. So really, if I integrate this from -2 to 2, because it's symmetrical above and below the axis, I should get 0. So let's just see what happens. So I've got x to the 4th over 4 minus 2x squared, and I'm going to go from -2 to +2. All right, so at +2, I know that this is going to be -4. And again, you can figure that out if you want. You just plug in 2 for x. Then you're going to subtract the value at the bottom. So figure out the first, and then subtract this one. So this is going to be -4 minus -4. So that's going to get me to 0. So from -2 to 2, you can see that the math works out. 4 minus 4, and that's going to get me that 0. And this works that way because it's symmetrical. It's not for every single function. And just one last thing to kind of point out as a reminder. Remember, said it a few times, but you're going to plug in this value first. Then you're going to subtract. You have to subtract because think of it as like you're figuring out what it is all the way up until that point. And then you're going to subtract everything. Like let's say we just have, this is scratch paper. Don't feel like you have to copy this, right? You have some crazy curve that looks like that, right? So, and here's your B, here's your A. Well, really, you can think of it like this, or here's how I think about it. I'm not sure if it's really technically correct, right? But we're figuring out the area all the way up until B, and then we're figuring the area all the way up until A, and so then if you subtract those two, whatever you're getting is going to be that area that's left in between A and B. So just remember this first, then subtract this one second. All right, hopefully that's a good kind of conceptual lesson as far as what the fundamental theorem of calculus does and looks at. So it should be kind of a good way to get going. And then after this, really, once we get the concept of this down, a lot of this is going to be techniques with integration, like how can we take these derivatives backwards, sort of, and how it all works out. So there you go.